Hello everyone. Today I'm going to discuss non-stoichiometric defects. Okay. Here non-stoichiometry means what? First of all, you should know what is non-stoichiometry. Stoichiometry and non-stoichiometry. In previous sessions about stoichiometry we have discussed, which is related to whole number ratio for given any formula or any molecule or any formula unit. If whole number ratio is there means we can say it is stoichiometric. Non-stoichiometric means there is no whole number ratio for the given formula for any given molecule. Many molecules we have like C6H12O6. It is a stoichiometric compound. If sometimes some ionic compounds or crystalline solids may not have stoichiometric ratios. Here we can take like this. Here I am taking Fe 0.93O. See, instead of FeO, ferrous oxide formula, Fe1O1, it is 1:1 ratio. But here the number of irons are less than 1, that is 0.93, and number of oxygens are 1. So it is not 1:1 ratio. It is not like 2:3 ratio. Fe2O3, it is ferric oxide. It is stoichiometric compound. But Fe 0.93O1 is not stoichiometric compound. So here is a non-stoichiometric defect. So due to missing of some cations or due to missing of some anions, otherwise both, if disturb the stoichiometry of the compound or crystalline solid, we can say it is non-stoichiometric defect. Due to defect in the sense by missing either cation or anion or both from the crystal lattice or crystal solid in any way by heating or any other disturbance. So due to this, if stoichiometric of the compound is disturbed, means it is a non-stoichiometric defect. If stoichiometry is not disturbed, that is a stoichiometric defect. Okay, here we have two types of non-stoichiometric defects here. One is metal excess defect, other one is metal deficiency defect. First, we'll discuss among these two. One is metal excess defect. Other one is metal deficiency defect. Metal deficiency defect. There are the two types. Non-stoichiometric defects are of two types. One is metal excess defect. Other one is metal deficiency defect. In metal deficiency defect, for example, here M is the metal, or here some along with some oxygens are there. Metal deficiency defects means if, for example, M1 O1. Here metal excess defect means here also I'm writing M1, for example, MO is the formula. M1 O1. This is stoichiometric. Due to this defect, if metal is somewhat excess, that means we can write it is changed to M1 plus XO. Means some of the metals are indirectly excess compared to oxygen here, or more compared to oxygen. Here metal deficiency. Deficiency means here it is changed to M1 minus X. So some of the metal atoms are decreased from 1 here. So O is common. This is simply we can take like that formula for metal deficiency defect and metal excess defect. First, we'll discuss about metal excess defect. Then after we'll take metal deficiency defect. Here, first I'm taking metal excess defect. Metal excess defect. These are of again two types. Metal excess defects are of how many types? Two types. In this first one is metal excess. Metal excess due to Here metal excess effect is due to anionic vacancies. It is anionic vacancies. Second one is metal excess is due to presence of extra cations at interstitial site. First one is metal excess due to anionic vacancies. Second one is metal excess due to presence of extra cations at interstitial sites. So first we'll discuss this one. Metal excess due to anionic vacancies we'll discuss. Here first I'll write examples. Here sodium chloride crystal heated in the presence of sodium vapor by using sodium vapor lamp. Otherwise, by using sodium vapors we have to heat sodium chloride crystal. Then it changes to yellow. So here metal excess defect due to anionic vacancies, otherwise called as F center defect. What is F center? We'll discuss. It is also called as F center defect. What is F center? We'll discuss in the continuation of this class. NaCl is heated in the presence of sodium vapor, so it becomes yellow. That means what here they may ask some questions like what is the color of sodium chloride when it is heated and why it is so. And reason also you have to remember and color also you have to remember. Sodium chloride like crystals shows yellow color when light falls on the sodium chloride crystal, solid crystal. It can show or exhibit a yellow color due to what? Due to excitation of electrons from the crystal lattice. So those electrons are due to this heating process. Means during this heating process there is a creation of some free electrons due to defect, due to anionic vacancies. How these anionic vacancies are created, we'll discuss after giving some more examples. See, one more example I am taking here. Here I am taking lithium chloride also. Lithium chloride when heated, like said, delta sign you know, the symbol for heating. Whenever it is heated, in the presence of what? Lithium vapor here. In this way I am writing. Lithium vapor. So it shows a pink color. It's lithium chloride crystal only, but it gives at imports pink color. Similarly, one more example I am giving. KCl when it is heated in the presence of potassium vapor. Whenever it is heated in the presence of potassium vapor, it can give violet color. It is also potassium chloride only, but it can give violet color. Otherwise, you can say lilac color. So, color of some ionic crystals due to what? Color is yellow color of sodium chloride or pink color of lithium chloride. Otherwise, violet color of potassium chloride when they are heated in the presence of their respective element vapors. Sodium chloride is heated in the presence of sodium vapor. Lithium chloride is heated in the presence of lithium vapor. Potassium chloride is heated in the presence of potassium vapor. Then they can show some colors. Those colors are due to this defect. This is the first important thing. They may ask like these questions. Here I am taking first example, sodium chloride heated in the presence of sodium vapor. Means here excess of sodium in sodium chloride gives yellow color. Like that also statement questions they may give. Excess of lithium in lithium chloride when it is heated in the presence of lithium vapor produces pink color. Otherwise the potassium chloride, otherwise excess of potassium in potassium chloride, like they may give excess of potassium in potassium chloride when it is heated with potassium vapor produces violet color or lilac color. It is due to this defect, metal excess. So how it is, we'll discuss now. Sodium chloride crystal I am taking. In sodium chloride crystal, one sodium plus ion and one Cl minus ions are present. Crystal lattice I am writing. Lattice means close packing. Lattice is nothing but what? Close packing of anions and cations. See here, sodium chloride I am taking. NaCl, any you can assume. These balls like I am writing here. This is one positive ion, maybe sodium plus or lithium plus or potassium plus you can take. Next, immediate to this, one negative charge ion. It is Cl minus here. Then again, immediate to this, one more positive charge. Here, negative charge. Here, near to this, we can expect negative because the positive charges and negative charges attracted together. So, two positive charges, if we write adjacent to each other, there exists some repulsions, so that you should not write in that way while representing the lattice here. So, here positive, then negative I written. Then here, this is positive. Then again, this is negative, positive. Just assume each sphere is one ion. Then similarly, here we can write positive, this is negative, this is positive ion, negative ion. And you can observe here, these are interstitial sites or empty spaces. Otherwise, you can say void spaces. That also you have to observe. So, these are interstitial spaces or void spaces or empty sites. Okay, here whenever this sodium chloride or potassium chloride or lithium chloride heated, if you take sodium chloride, I am heating this sodium chloride crystal in the presence of sodium vapor. Whenever sodium vapor by using sodium vapor when it is heated, some sodiums are deposited on surface of this crystal lattice. Some sodium, sorry, some sodiums are deposited. Here I am writing here when NaCl crystal, when NaCl crystal is heated in the presence of sodium vapor, the presence of sodium vapor. So some of sodium atoms are deposited on lattice, surface of the lattice, otherwise surface of the lattice. This is the first thing. Then see, for example, this is a negative charge ion, means Cl minus ion. Whenever it is heated in the presence of sodium vapor, here some Cl minus ions from the lattice, are escaped out from the original site. Cl minus ions from the lattice or missing of Cl minus ions takes place whenever the sodium chloride crystal lattice is heated in the presence of sodium vapor. Some of the Cl minus ions from the lattice are missing and they enter into the surface. See here, for example, this is the Cl minus ion I am taking. Cl minus ion leaves its original site and move to surface. Here I am writing Cl minus. Surface may be this area or this area, this side. From depth also we can take, from sides also we can take, from upside also we can take, top side also we can take. So Cl minus ion which is present here now leave its original site and enter into surface, enter to the surface. At the surface, as per this statement, some sodium plus ions, sodium ions are deposited here. When sodium chloride crystal is heated in the presence of sodium vapor, some of sodium atoms are deposited on surface. So some sodium atoms are present here on the surface, and because of this heating, Cl minus ions also leaves its original site and move to surface. So now, as to get one more sodium chloride ionic unit, otherwise formula unit, it must lose electron. This sodium is there, no? This sodium must lose electron. This sodium here, this is Cl minus now. This is Cl minus. This is Cl minus. Wait a minute. Here, clearing this sodium chloride. Example, it is here remedy. NaCl. NaCl is example. NaCl is example. See here from this is the up to here, this is the crystal lattice. This is the surface now. Whenever it is heated, some of the sodium atoms from the vapor, sodium vapor, deposited on the surface. This is a sodium atom on the surface. Now, because of this heating, Cl minus ions from the original site move to surface. So, as to get sodium chloride, there should be sodium plus ion along with the Cl minus ion. So, as to get sodium plus ion, this sodium which is neutral, which is deposited from the vapor, sodium vapor on the surface, now loses electron. Now loses electrons. This sodium now loses electrons and becomes positive. The electrons which lost by this sodium now move from or diffused from here to here. Before that, Cl minus ion diffused from this original site to surface, so that this is now vacated. This original site of Cl minus ion is vacated. So this is the now called as anionic vacancy. Anionic vacancy. Why it is anionic vacancy? Because anion is diffused from the lattice and move to surface as Cl minus ion only, and so that here anion space is now empty. So the same vacancy now occupied by the electron which is released by sodium atom, which is released by this sodium atom. So that this electron which is released by sodium atom is now occupies this site. So this center is now called as F center. Anionic vacancy in which electron is present, no, this site is called as F center. Actually here written F means 4 by 4 for Bunjender. Otherwise here 4, its meaning is color. Its meaning is color. So that because of these electrons, because of these free electrons, F center must contain free electrons. They are the free electrons. So due to these free electrons only, it can show which color? Yellow color. Just again, just now I given what are the colors of different crystals. Due to this only, it can show yellow color. Whenever light falls on the sodium chloride crystal, then by absorbing that light, the electrons which are present in F centers can get excited. Due to that excitation, it emits some energy. That emitted energy is appeared as yellow color. So this is the reason. This is about metal excess due to anionic vacancies. Now if you count the number of sodiums and number of Cl minus ions, one sodium is in excess due to one Cl minus ion is moved from the crystal lattice. So this is up to here, this is the crystal lattice. See here, this is the crystal lattice. From here, see 1, 2, 3, 4, 5, 6 positive charges are present. And how many negative charges must be present to maintain electrical neutrality? There should be 6 negative charges. But here 1, 2, 3, 4, 5. Only 5 negative charges are there. So to maintain electrical neutrality, the electron which is released by this sodium comes here. So this center, this anion vacancy is occupied by that electron which is released by sodium. That you have to remember. Many times I have seen this question. In F center defect, the electron is from, generally what we can expect, Cl minus ion is eliminating from here, so that the electron is from Cl minus ion we may think. But that electron is not from Cl minus ion. Cl minus ion remains as. But the electron which is released by sodium which is present on the surface enter into this interstitial, not interstitial site, this anion we can see, so that it can import color. Which color? Yellow color. So this is the information here. What we can write? See here. What happened when sodium chloride crystal is heated in the presence of sodium vapor, some of sodium atoms are deposited on surface of the lattice. So here by absorbing here some more statement writing, by absorbing heat, Cl minus ions, Cl minus ions which is anion, Cl minus ion, this side I am writing. Here I am writing. This is the anion vacancy, otherwise F center, otherwise color center. F center, otherwise color center. Inside is color center. Okay, let it be here. By absorbing heat, Cl minus ion diffused from its original site, original site, and move to diffused from its original site to surface and surface. And here one more statement is sodium atom in the presence of the Cl minus ion. Sodium atom present, sodium atom present on the surface loses electron. Sodium atom present on the surface loses electron and forms NaCl. When it combines with this Cl minus ion, forms NaCl. So here electron lost by sodium, again sodium lost by sodium diffused to anion vacancy. Anion vacancy, which is nothing but F center. So this much information if you write, it is enough for metal excess defect due to anionic vacancies. Okay, this is about metal excess defect. Okay, in next session we'll discuss about metal excess defect due to presence of extra cations at interstitial sites. Okay, thank you.